Okay, so here is our third video in the Law of Sines Ambiguous Case series. In the last case, we took a look at a situation where we had an obtuse angle with one triangle possible. Okay, in the video before that, we went through our 6 possible scenarios. All right. Now, notice, I wanted to point out as I thought about this, when I drew my initial triangle here, I just drew it as a graphic organizer. This is certainly not a 96-degree angle. It doesn't even look obtuse. It isn't obtuse. So when we're drawing our triangles, they are just graphic organizers, okay? Sorry if you hear my dog barking in the background. Someone's walking by and that's his job. So anyway, back to the math. Remember, these triangles are just graphic organizers. I'm going to set them up the same way every time when we're dealing with a side-side angle case. Okay? So the next one, I'm going to draw it exactly the same way as I alluded to previously. Got my ray down here at the bottom. I don't know if I have a triangle yet, so I'm just going to draw this like I did last time. Okay? My angle that I'm given, C, in this case is 63 degrees. Side C, which is across from it, is 8. Side B will have to be my adjacent side, and that's 11. Now this, if this does create a triangle down here, this would have to be angle B, because it would have to be across from side B, and the leftover one would be A and side A. Okay. Now, as I look at this, I notice that the angle given here, angle given is acute. All right. So when I look at my table, I'm looking over at the stuff here on the right. These 4 situations. Most of those situations, 3 out of the 4 of them, have to do with comparing the opposite side to the altitude of the triangle. One of them, and this is a real quick check, just looks at, is that opposite side bigger than the adjacent side? Okay, is the side opposite bigger than the side adjacent? So let's just look to see what the case is. Is this opposite side bigger than the adjacent side? And no, that's not the case. So I'm going to have the situation where I need to compare everything to the altitude of the triangle. So here's my altitude. And that altitude will be found by taking the adjacent side, 11, times the sine of the angle. So 11 times the sine of 63. My calculator is still in degree mode from my last video, so I don't have to check for that. So I'm just going to 11 times the sine of 63. And that comes out as 9.8. All right. So what I notice is that this side opposite is 8. The altitude is 9.8. So my side opposite is less than the altitude. So if I look back here, I have the situation where the side opposite is less than the altitude, which was this situation. So there's no triangle. I don't have to complete anything. I'm done. There are no triangles possible. All right, so that's just simply my answer. No triangles to solve. Okay, and again, that was because the altitude that I found, 9.8, was larger than that opposite side of 8. Okay, cool. So let's go ahead and look at another one while we're at it. This is one of my favorite word problems. It's a cool astronomy type of thing. It says the distance from Mercury to the Sun is about 36 million miles. The distance from Earth to the Sun is about 93 million miles. Estimate the distance from Earth to Mercury if the observed angle between the Sun and Mercury is 19 degrees. All right, so we have to figure out how we're going to set this problem up, and then we'll go ahead and work through some stuff. Now, the way I've been telling you to set these up will really take out a lot of the guesswork. Okay, got our ray. It's our angle, opposite side. Now, in this situation, we're on Earth. Okay, here's Earth. And there is an observed angle between the Sun and Mercury. And that's going to be at this angle here. Okay, and that's 19 degrees. And here is Mercury. And here is the Sun. And then it says that the distance from Earth to the Sun is about 93 million miles. And it says, let's see, does it give us the distance from Sun to Mercury? Yeah, Mercury to the Sun is about 36 million miles. Okay, cool. So now we have an acute angle. So the first thing I'm going to do, just like in the last one, is compare to see the bottom right-hand situation, which was where the opposite side here was bigger than the adjacent side. Is that the case? Is the opposite side bigger than the adjacent side? 36, that's definitely not bigger than 93, so that's not the situation. So now what I need to do is to compare this opposite length to the altitude of the triangle. And that will be done by 93 times the sine of 19. Okay, so 93 times the sine of 19. That altitude comes out to 30.3 approximately. 30.3. Okay, so the opposite side of 36 again is bigger than the altitude of 30.3. So if I look back here, the opposite side is bigger than the altitude, which is this case. It is less than the adjacent side, but bigger than that altitude, so it actually forms two triangles. All right, so I'm going to have one triangle. I'm going to resketch both of them, actually. I think that'd be a good idea. I'm going to have one triangle that looks like this. Okay, here's M, here's S, here's E, 93, 36, and 19. And then I'm going to have a second triangle that looks like this. E, M, S, 93, 36, 19. All right, so I have two situations to solve for. I'm going to take my right down the middle there. And what we want to know, the question is actually asking us for, is to estimate the distance. Let me highlight this. Estimate the distance from Earth to Mercury. Okay, so what I want to know is this distance from Earth to Mercury. All right, well, we've got a few things we've got to do to solve this. First thing I have to do is identify my angle side pair. Angle side pair is this. Okay, I'm going to label this side E to help us go through things. And here's my angle side pair in this one. All right, E. And then what I'm going to do is I'm going to find the next closest completed angle side pair, which is M. And that's this. So this is going to be side M. This is angle M. And then here, okay, we'll have to wait a moment to be able to figure out what angle S is. Okay, so let's set this up. I'm going to go ahead and say, all right, well, the sine of 19 over 36 is equal to the sine of whatever angle M is over 93. Cross multiply. 93 times the sine of 19 equals 36 times the sine of M. And divide by 36. Now, I know some of you are right now saying, why did he cross multiply? Why didn't he just multiply by 93? That multiplying by 93 is definitely the quicker way to do it. I'm just showing you a method that works in every situation. Same process, that cross multiplying. That will always work. It's not always the shortest method, but it always works, okay? So 36 cancels, and the sign of m then, the sign of m is equal to, all right, let's do some number crunching. 93 times the sine of 19 divided by 36. It's out to 0.841. All right, 0.841. And now what I'm going to do is I will take the inverse sine of both parts. All right, now to help me over here on the right, I'm just going to use the magic of electronics. There we go. Inverse sine. And the inverse sine, or the arc sine for the old school folks. So second sine, second answer, enter. We get 57.25 degrees. 57.25 degrees equals m. Now, this is a cool moment here, gang, okay? Because what happened is we have two different triangles, one on the left and one on the right. 57.25 is an acute angle. This measurement right here fits better with the drawing I did over here. All right, because that one is drawn in as my acute angle. All right, so that is 57.25 degrees, and this angle here, okay? So over here, I'm going to say m equals 57.25 degrees for that triangle. So what do we do for the one on the left? Well, we're not left out to dry here. Get it? It's the triangle on the left, and we're not left out to dry. Sorry, bad humor. Saturday afternoon making math videos. We're going to have some fun. What the m on this side is actually going to be the supplement. Okay? So what I need to do then, well, is almost the supplement. What I need to do is I need to find, well, it is, yeah, it's a supplement. I need to find the supplement to 57.25. So I'm just going to go 180 minus 57.25, which is 122.75. 122.75. There we go. That is the measure of angle M on this side. Okay, so we're not left out to dry. We have our obtuse angle, we have our acute angle, so we're good to go still. It's just the one I found fits better on the right-hand picture than on the left-hand picture. So now what I'm going to do is I'll find angle S. Now angle S will simply be 180 minus the 19 for angle E minus the 122.75 for angle M. So we go 180 minus 122.75. I'm doing this out of order, sorry. Minus 19. We get 38.25. Angle S equals 38.25. And now I can solve for side S. Whew, a lot of work, right? But this is an awesome problem. Way beefy. Very cool. So we finally go back to that angle side pair we started with, 19 and 36. So sine of 19 over 36 is equal to the sine of 38.25 over, and we should call this side, the distance between Earth and Mercury, side S, because it's opposite angle S. So over S. Cross multiply. S times the sine of 19 equals 36 times the sine of 38.25. Divide by the sine of 19. Sine of 19. And S comes out to be, if I had a drum roll, this would be perfect time for it. 36 times sine of 38.25 divided by the sine of 19. We get 68.46 million miles. Wow, this is a long ways. It's a lot further than to my grandparents' house. Holy cow. 46. There we go. Million miles. Million miles. Whoa, sounds like Dr. Evil or something, right? We were dealing million miles, right? Yeah, millions of miles. Very cool. Well, we're almost done. Yeah, almost. Okay. So what we need to do now is we have to solve for the situation where Mercury is actually further away from Earth. Yeah, the one on the right, where Mercury is even further away. So what we're going to do is we'll find the measure of angle S. So in this case, angle S was going to come out to be 180 minus 19 minus 57.25, this smaller value, the acute value for angle M. All right, so 180 minus 19 minus 57.25. All right, 103.75 is angle S. So now that is our acute angle. Okay, so angle S is 103.75. That is our obtuse version. Did I say acute before? I don't know. If I did, I'm sorry. S is the obtuse angle in this situation. Okay. Yeah, so let's finish this sucker off. So now I'll go ahead. We're almost done. Sine of 19 over 36, my original angle side pair, is equal to the sine of 103.75 over side S, and this is side S in this case. Cross multiply. So S times the sine of 19 is equal to 36 times the sine of 103.75. Divide by the sine of 19. Divide by the sine of 19. Boom, boom. S is equal to, oh man, we're almost home free. Here we come, Mom. Hope dinner's still warm. Sine of 103.75 divided by the sine of 19. Enter. Enter. Got nervous for a second. All right, we come out with 107.41 million miles. Two possibilities for the sun's, or sorry, for the distance between Earth and Mercury. All right. Now, that's the end of the problem. We have both solutions, but why in the world would we have two solutions? Why does that why is that even possible? This is why. We're sitting here on Earth, right? And here's the sun. Well, we all know that planets rotate, right? So we've got Mercury out here rotating around, and what happens is Mercury, this is poorly drawn, sorry, Mercury is going to have two places where it comes in the line of sight for Earth as Earth looks across here. Okay, so we've got this line of sight between Earth and the sun, and then with Mercury passing through, it hits right here and right here, creating two different triangles. It creates a triangle here okay, which was the triangle we solved for on the left. And then it also hits and creates a triangle like this, which was the triangle we solved for on the right. That's why we have two different triangles. All right? This is a pretty advanced thing to wrap our heads around, but we see it happen in machinery all the time. I mean, gosh, think about the motion of our pedals on a bicycle. We see this in many different situations. Even on the playground, we could see it with a child on a merry-go-round if they still have those. And definitely, as we saw here with astronomy, there's many applications, so we need to be able to handle it. This is a long video. I think you deserve to go get yourself a drink of water, maybe a coffee. That's what I'm going to do. And enjoy the rest of your day. Thanks for joining me, and that's the end of the Law of Signs series of videos. Toodles!